Hello. Today we're going to be solving trig equations, and our essential question is how do we solve trig equations using the unit circle, identities, and algebraic means. So we're going to go ahead and start off with our first example. This one we're going to be using algebra and the unit circle to help us to solve this equation. So we have the equation cosine of x plus 3 equals 3, and we want to solve it over the interval 0 to 2 pi. Notice that we have the brackets, so we're including both 0 and 2 pi as possible solutions. So the first thing we're going to do is we're going to get this so that we get the cosine of x isolated. So we're going to subtract 3 to both sides. And when I do that, I now have cosine of x is equal to 0. And at this point, cosine is isolated. So now I'm going to go look at my unit circle and I'm going to ask myself the question, where is cosine of x equal to 0? And so as I look on my unit circle at 90 degrees, well, at 0 degrees, our ordered pair is 1, 0. Remember, cosine's the first value of the ordered pair, sine is the second value. So at 0 degrees and 2 pi, we have the ordered pair 1, 0. Over here at 180 degrees, or pi, we have the ordered pair negative 1, 0. So up here at 90 degrees and pi over 2, we have the ordered pair 0, 1. And down here at 270 degrees or 3 pi over 2, we have the ordered pair 0, negative 1. So you'll notice that at these two locations, at pi over 2 and 3 pi over 2, we have our cosine value being 0. So our solution, since we are looking from 0 to 2 pi, which means we're going all the way around the circle, everywhere that cosine of x is equal to 0 is pi over 2 and 3 pi over 2. So these would be the solutions to the equation cosine x plus 3 equals 3. Go ahead and pause, copy that down, and we'll move on to a second example. Alright, our next example, we have 8 sine of x minus 4 radical 2 equals 0. We want to solve this over the interval 0 to 2 pi. So let's go ahead and start out with some algebra. First thing we're going to do is add 4 square root of 2 to both sides. Again, we're trying to isolate sine of x. So we end up with 8 sine of x equals 4 square root of 2. Now we're going to divide both sides by 8. So that the 8 cancels out over here, so we're left with sine is equal to, now 4 over 8 is going to reduce to 1/2, or we're going to have a 2 in the bottom, so we end up with the square root of 2 on the top and 2 on the bottom. So now what we're going to do is go look on our unit circle, and we're going to try to find the places where sine is square root of 2 over 2, and it needs to be positive. So if I come up here to my unit circle, there are 2 locations where sine has a positive square root of 2 over 2, and that would be at 45 degrees or pi over 4. Again, we're looking for the second value of each ordered pair. So at this location, and the second place where sine is going to have a positive square root of 2 over 2 is going to be over here in the second quadrant, and that would be at 3 pi over 4. That's where our sine value, the second value of our ordered pair, is positive square root of 2 over 2. Not worried about the fact that the cosine is negative. I'm only looking at the sine value, which is positive. So I seem to have lost my x here. So x is equal to pi over 4 and 3 pi over 4. Go ahead and pause, finish copying down this example, and we'll move on to a factoring or square root type of problem. Now before we move on, I want to just give you a quick way to remember where your functions have positive values. In the first quadrant, all of your functions are going to have positive values. In the second quadrant, sine is going to have positive values. And in the third quadrant, tangent will have positive values. And in the fourth quadrant, cosine will have positive values. So an easy way to remember this is using the acrostic. It's ASTC, which stands for all students take calculus. The A for all, the S for sine, T for tangent, C for cosine. And remember that you're doing this in a counterclockwise direction. Let's go ahead and pause and copy that down, and then we'll get to the example. Okay, next example. We've got 4 sine squared x minus 1 is equal to 0. So now we are going to solve this one using square roots. We want to solve it over the interval 0 to 2 pi. So let's go ahead and get started. First thing we're going to do is do our normal algebraic processes. So we're trying to isolate the sine squared of x. We're going to add 1 to both sides. So we've got 4 sine squared x equals 1. Now we're going to divide both sides by 4. So we have sine squared x is equal to 1/4. And then the last thing we're going to do to get rid of the square is we are going to square root both sides. So let's go ahead and square root both sides. Now remember, when you do this, when you put a square root into the problem, you must consider positive and negative possibilities. Square root of sine squared is sine of x, and then the square root of 1/4 is 1/2, because 1/2 times 1/2, multiplying the numerators gives me the 1, multiplying the denominators gives me 4. And this is going to be positive or negative 1/2. So now when I go look at my unit circle, I want to know where are all the locations that sine is either positive or negative 1/2. And my first location is going to be at pi over 6. So we have the ordered pair, square root of 3 over 2, positive 1/2. So there's 1. Second location over in the second quadrant is at 5 pi over 6. Our ordered pair is negative square root of 3 over 2, positive 1/2. Third location, because it can also be negative, it's going to be down here in the third quadrant at 7 pi over 6. Where we have the ordered pair negative square root of 3 over 2, negative 1/2. And then our final location will be in the fourth quadrant. Similar location. This one is at 11 pi over 6. And that ordered pair is negative or positive square root of 3 over 2, negative 1/2. And so you'll notice on this one we actually have 4 solutions. And anytime you have a square in the problem, like we did initially, you're going to have the possibility of having twice as many solutions, and you can see that is the case. Let's go ahead and pause, copy this example down, and we'll move on to one more example. Okay, last example. We got 3 cotangent squared x minus 9 is equal to 0, and we want to solve over the interval 0 to 2 pi. So let's go ahead and get started on this. First step, trying to isolate our cotangent squared, so we're going to add 9 to both sides. So we have 3 cotangent squared x is equal to 9. Now we're going to divide both sides by 3, and we get cotangent squared x is equal to 3. Now what we have to remember is we don't see immediately on our ordered pair tangents or cotangents. What we see are sines and cosines. But if we will recall, cotangent is equal to cosine over sine using our identities. So here in a moment, when I take the square root of both sides, I'm not going to see square root of 3, positive or negative, directly on my unit circle, but keeping in mind that cotangent is cosine over sine, what I'm going to do is take my cosine value and divide by my sine value so that I get the square root of 3. Okay, so let's start with our first quadrant. We have 2 locations where we have square root of 3 involved in our ordered pairs. The first one is at pi over 6, second one is at pi over 3. At pi over 6 we have square root of 3 over 2, comma 1/2, and at pi over 3 we have 1/2, comma square root of 3 over 2. So if I take those 2 possibilities and I set it up as cosine over sine, at pi over 6 we're going to end up with, as our cosine over sine, we will end up with square root of 3 over 2 divided by 1/2, versus at pi over 3 we will end up with, for our cosine over sine, we would end up with 1/2 divided by square root of 3 over 2. Now if I take those and I do my fractional division, remember when we divide fractions we keep the top one the same. We change the division to multiplication and we flip the bottom fraction. So for pi over 6, I end up with square root of 3 over 2 times 2 over 1. The 2's cancel, so I end up with my square root of 3 that I need. If I had done pi over 3, I would end up with 1/2 times 2 over square root of 3, which then, before simplifying that further, I end up with the square root of 3 on the bottom, which is what I don't need. So pi over 6 is going to be our first solution. And then our other solutions will be at similar locations with the same reference angle in the other quadrants. Now, because they can have either positive or negative, I will be able to go all the way around the circle and pick up those additional locations in all of the quadrants. So pi over 6 will be one solution. 5 pi over 6 would give me a negative solution. Remember, in that third quadrant, tangent is positive. All students take calculus. So tangent's positive over here, so we would get another positive square root of 3. And then in the fourth quadrant, we would get a negative square root of 3 at 11 pi over 6. And this location in the third quadrant is 7 pi over 6. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 are our solutions for 3 cotangent squared x minus 9 is equal to 0. Go ahead and pause, finish copying this problem, and finish up your notes quiz. Have a good day.